For our next example, Andrew kicks a ball uphill for his dog, Leica. I guess that's how we're going to pronounce it. The hill is modeled by a line through the origin. So you can see that here. It's this blue line, y equals 0.5x. And then the path of the ball is this quadratic. That's obviously that. And here's the equation for the quadratic. We want to know how far does the ball travel horizontally. Okay, assuming the dog runs up the hill and catches the ball. So we basically want to know this point of intersection. That's what they're asking us for. So we want to solve this system of equations. Now the great thing is this is already solved for y. It is all set up for substitution. We're going to take that and plug it in over there. So we get 0.5x equals negative 0.5x squared plus 6x. Just like we did on the last one, we want this equal to 0 so that we can factor out our quadratic formula or whatever we end up deciding to do with it. I'm going to subtract 0.5x from both sides, which gives us 0 equals negative 0.5x squared plus 5.5x. This has a GCF. Okay, let's factor out the GCF. Do you see that they both have an x that can be factored out? So we can't actually factor this, even though it's got weird decimals. So that gives us negative 0.5x plus 5.5. And then we're going to set both of those equal to 0. So either x equals 0 or negative 0.5x plus 5.5 equals 0. And when I should have written this somewhere else, I can't fit it. We subtract 5.5 from both sides and then divide, we find out that x equals, I can grab my calculator. So I subtract 5.5 and divide by negative 0.5, 11, okay? So that means they intersect here at x equals 0, which obviously that's where they started, and then over here where x equals 11, okay? And that's all we have to find, because remember it was asking how far does the ball travel horizontally? Well, right there. That's it, 11. Now, how far must Leica, the dog, whatever, run up the hill to catch it? So we want to know how far this is going to be. Well, let's see. If we made a point out of this, 11 something, if we wanted the y value, we're just going to plug back in. I definitely recommend plugging in here. So 11 times 0.5 is 5.5. So this point right here has an x-coordinate of 11 and a y-coordinate of 5.5. And you see I've just drawn this nice little right triangle? We can use Pythagorean theorem to find the distance that the dog runs up the hill. So we'll do 11 squared plus 5.5 squared equals d squared. That we can just rely on our calculator for. I can trust you to do that work, I assume. So the dog has run 12.3 feet up the hill. That's not very far. I think Andrew should throw the ball better. All right, let's try another one. Revenue for one high school band concert is given by the function y equals negative 30x squared plus 250x. X is the ticket price in dollars. The cost of the concert is given by this other function, 490 minus 30x. At what ticket price will the band make enough revenue to cover their cost? So this is asking us at what ticket price does their revenue, the amount of money coming in, equal the cost going out? They want to break even. So these are already set up. The revenue equation is negative 30x squared plus 250x. The cost equation is 490 minus 30x. We just need to solve that. It's already kind of set up for substitution. So I'm going to start by getting everything to the same side. Plus 30x minus 490. That does not have a like term over here. I'm just going to stick it there. Sorry. Got a little sloppy there. So we get negative 30x squared plus 280x minus 490. Those are big numbers. There's a GCF of 10, but I don't think I really want to factor this. So if we don't want to factor, a quadratic formula is going to be our best bet. So to solve this, we're going to do x equals negative b plus or minus square root of b squared, was an 8, minus 4 times a times c, all over 2 times a. All right, so we get negative 280 plus or minus. The part under the square root, you're going to go straight to your calculator with. We get 19,600 over negative 60. I don't know, is that a perfect square? Oh, it is. I guess we could have factored this. Nobody wants to factor that. That would have been a mess. So negative 280 plus or minus 140 over negative 60. Okay. Now, that's two different answers. I'm going to come over here because I'm really short on space on that side. Okay, we're going to find those two answers. So the first one is x equals negative 280 plus 140 over negative 60. So let's see what that is. Negative 280 plus 140 divided by negative 60, which is 233. And then the other one is x equals negative 280 minus 140 over negative 60. So negative 280 minus 140 divided by negative 60. So 7. So at what ticket price will the band make enough revenue to cover their costs? We actually have two different answers that make sense here. We could price our tickets at $233. We could price them at 7. Let me show you what's actually happening here, okay? This revenue function is a parabola that's opening down, okay? So something like this. I don't know what it really looks like. And then the cost function is a line, okay? It looks like that. So we have 2 points. We found the 2 points. So really, at any point in between those, we'll be making enough money to cover the cost. If you go below $2.33, you're not charging enough for the tickets, so you're not going to cover your costs. If you charge above $7, I don't think many people will come. It's because you're charging too much. This must be a pretty terrible play. No one else can see it. Okay, so that's what these look like. We will do some inequalities and